Hello and welcome to the third installment in our series on laboratory equipment. My name is Bailey Adams. In this video we'll cover the use of the digital multimeter. For this demonstration we'll be using the HP 34401A digital multimeter, which is the same as the Agilent 34401A and similar enough to most equipment you should come across in the field. Remember that quick start guides and equipment manuals will be available on your course website. The multimeter is your friend. It is a powerful tool for debugging your circuits. It allows you to readily and accurately measure voltage, current, and resistance to check the performance of your circuit against your calculations. You can measure either DC voltage or the RMS value of AC voltage. You won't be expected to know what AC voltage is at this point in the class, but later on you may want to use this function, so I'll go over it quickly. The circuit I'll demonstrate looks like this: an AC voltage source in series with a resistor. The AC voltage source is provided by the function generator, which is providing a 1 kHz wave at amplitude of 100 millivolts. Attach to the output, and then attach the function generator, which is your AC source, to your resistor, like so. Now we turn on the multimeter and set it to measure AC voltage with the ACV button, and attach two leads, one in ground, there, and one in the voltage slot up here. Then attach your leads across the resistor in the same way, red to red and black to black. And here's your reading. 100 millivolts reads as a little over 70 millivolts on here because this is an RMS value. When making these measurements, you should keep in mind that they're only accurate up to about 1 megahertz signals. Anything higher than that and your measurement is garbage. Watch, I raise the frequency of the signal past 1 megahertz and the multimeter can't keep up. The online specs say the measurement is accurate to within 1% up to 100 kilohertz. Now to measure DC voltage, you do the exact same thing, except you press DCV. You attach the leads in the same way. Use black for ground by standard, red for high. Ring down here, we have a 5-volt DC power source all set up, connected to our resistor. We attach the ground and lead of the voltmeter across the resistor, and our reading is 5 volts. Here's what our example circuit looks like, and here it is with the voltmeter attached. The voltmeter function is modeled by a large or infinite resistance in parallel with an ideal voltage meter, one that draws no current. So it is effectively an open circuit, and thus won't affect your circuit. In practice, our voltmeter resistance is 10 megaohms, so if the resistance of your circuit between the terminals under test approaches this, the reading will not be accurate. Please note that the voltage is a relative measurement. You're measuring the voltage on your red lead in reference to your black. So this is 5 volts above this point. If you want to switch the wires, making this your new ground for your circuit, and measuring the voltage at this point, it is -5 because this voltage is still 5 below this. The measurement is made by taking the voltage here and subtracting the voltage here. By convention, red is positive, black is ground. We'll call this VA and this VB. Then you take plus VA minus VB and you get your measurement. If your measurement is positive, then it's a voltage drop, which means the voltage here is higher than this one. If the measurement's negative, then it is voltage rise, and the opposite is true. To measure DC current, we want the DCI option, so we get shift, the DCV button. Units are now in milliamps DC. For our circuit, we come down to the 5-volt power source, plug this wire into the top. This wire runs along to our resistor, comes with the other wire up to the ammeter. We use this lower circle for that, and then out we use the same ground we were using before and bring that down to the ground of the power supply. And now we have 5 volts across a 1 kilo ohm resistor, and we get a 5 milliamp reading, which is correct. This is what our circuit looks like right now. Say we want to measure current at this point. Then this is how our circuit should look with the ammeter correctly placed. Ideally, the ammeter is a wire, so it shouldn't affect your circuit. It can be modeled as a small or zero value resistance in series with an ideal current meter, one that has no voltage across it. Do not place the ammeter like this. The ammeter is a wire, so your circuit changes and becomes this, and you're measuring this current versus this one. You may notice that ideally this current is infinite. In reality, the current is determined by the resistance of these wires, which is very low but not zero. In order to avoid damage to the multimeter or to your circuit, the multimeter is fused at 3 amps. Any higher than that, the fuse will blow. Now on to resistance. Disconnect all power to your circuit in order to get an accurate reading and not damage the equipment. Disconnect these leads. Press the 2-wire resistance button here to get an ohm meter, and then connect 2 leads between the shared ground and the one that you used for voltage. These wires go between the thing you want to measure in your circuit, in this case just a 1 kilo ohm resistor, and that is roughly 1 kilo ohm. In order to measure resistance, the ohm meter puts a small current through your circuit and then measures the resulting voltage across, and then calculates resistance by Ohm's law, R equals V over I. This is why you don't want any current running through your circuit from an external power source. It messes up the reading. In addition to using the ohm meter to measure the resistance of actual resistors, you can also use it to check your wires. If I put this normal blue wire between the 2 terminals of the ohm meter, it will give me a very low resistance, which is to be expected of wires. If I put this broken yellow wire between the 2 terminals, then it will still give me overload, which means that there is a break somewhere in the wire and you can't use it in your circuit. One final note. On cheaper multimeters, you have to manually select the range of measurements you want to make. Luckily for us, our nice tabletop multimeters auto-range for us, so we don't have to worry about this. That's all for the digital multimeter. Remember to take care when connecting it to your circuit, and as always, feel free to ask your lab assistant for any advice or clarification.